Okay, sounds good. Hi everyone. My name is Alex, and I've been a full stack developer since 2014. I worked for several large and small companies, and I've been using various DevOps tools and practices extensively, including cloud infrastructure like AWS, Google Cloud, Microsoft Azure, and so on. If you want to contact me, please feel free to reach out on LinkedIn or Telegram. And for training services, you can also find me on coding bootcamps. All right. In this presentation, I'm going to cover 4 different kinds of architecture, but I want to emphasize that it doesn't mean that any program should have just one kind of architecture for the entire system. Actually, in the same system, you can use for various parts and at different levels pretty much all these kinds of architecture. Yes, I started recording. Yeah, so let's start with the monolithic architecture, which is probably the oldest one and is best understood because it's the simplest one. And it pretty much consists of several layers. Usually you have a database layer, business logic layer, and a user interface layer. So all these layers communicate with each other directly inside the same process on the same machine. So that's where you have these pros and cons. A monolithic architecture is usually simpler to develop and deploy because everything is in just one repository in the source control system, like Git, for example, and you can just deploy the entire repository with one click to your one production machine. Also, the monolithic architecture has fewer cross-cutting concerns, meaning that you don't interact with different services. Everything is just in one place. And in some circumstances, monolithic architecture can have better performance because everything is running on the same machine in the same process. You don't need to switch from process to process, from machine to machine. You don't have network interactions between services, which usually results in better performance for simple transactions. And that's why monolithic architecture can still be used, and in many applications it's actually more preferable to use this architecture, especially in small startups, and if you're just trying some idea, you can start with a monolith and refactor it into microservices or service-oriented architecture later on. So you don't need to necessarily decide upfront and design a very complex system from the very beginning. But at the same time, of course, the monolithic architecture has several cons. First of all, the code base gets very difficult to reason about if it's large. Usually over time, with adding more and more functionality, the communication between different components inside the same large code base can be very complicated, and it can be hard to understand which function calls which. As also, it can be difficult to adopt new technologies because if you, for example, just want to upgrade to a new programming languages version, for example, if your existing code base is written for Python 2, for example, and you just want to upgrade it to Python 3 for some reason, it can be difficult because it can be incompatible with the existing code. So if you ever decide to adopt a new programming language or a new platform, you'll probably need to rewrite all your code base, which is large, from scratch, which is expensive. And also it allows for limited agility, meaning it's hard to deploy small changes because with every tiny change that you introduce in just one part of your large code base, you'll still have to redeploy your entire large repository like every time you introduce a new change. So the next evolution of the architecture was service-oriented architecture, which should not be confused with the microservices architecture, which is different. And the service-oriented architecture usually pronounced as SOA, consists of just one shared database, and just like with the monolith, but at the business layer, you have several separate services that do not communicate with each other directly. They do not call other services functions. Instead, they receive messages from the enterprise service bus, and they react to those messages, doing the business logic, probably persisting some state to the database, and also emit new events after they're done processing the previous message. So this architecture also has its own pros and cons, of course. The pros are it's easier to reuse your services, so you can share the same functionality across multiple code parts, which is harder to do with a monolithic architecture. Also, it usually has a better maintainability. With the service-oriented architecture, you can maintain your services separately from one another, so you can shut down one service and still have all the rest of your application system running. And also you can introduce updates separately to different services. Also, this architecture has a higher reliability because all your services are separate, of course. If one service for some reason shuts down or has an error in it, this error will not necessarily crash your entire system. So the system as a whole can still be functional. And it's possible to have a parallel development. You can develop different services with different teams at the same time. As for the cons of this architecture, it's pretty complex to manage, especially the event bus part, and handling messages can be not so easy to reason about compared to direct function calls. And you can have tons of messages just bloating your service bus, and can be hard to reason about all these communications and to react and debug this system. Also, this architecture has a higher infrastructure costs because you introduce new systems like enterprise service bus. It's not easy to set up it locally on premises, so you'll probably have to either use a cloud or have a large infrastructure team. So this architecture is more suitable for large enterprises like banks, for example. And it also has extra overload in performance, and because your services do not communicate directly inside the same process anymore. You have extra costs of network calls, and so these communications can be slower. The next architecture is microservices, which is probably the most advertised at the moment. And what it means, you basically have smaller parts of your system that run completely isolated from one another. So they have pretty much the same layers, but in each service it's contained. So each microservice will have its own database, its own business logic, and so they're pretty much self-contained. So this architecture has, of course, a lot of advantages. That's why it's so popular, especially in the cloud world, where it's easier to manage the infrastructure. So this architecture can be easier to develop, test, and deploy, because the services themselves are very isolated and have a much smaller code base by their own. Increased agility, and just like with the service-oriented architecture, you can develop and deploy and pretty much do all these steps independently for each service. You don't need to wait for another service to finish development or testing of your own. So it doesn't require much communication between the teams that develop different microservices. Also, it's easier to scale horizontally because microservices don't have shared state, unlike the service-oriented architecture, where the same database is being used by all the services. you can easily duplicate each service, like create clones, especially with Docker containers and with Kubernetes. It's really easy to duplicate containers and pods inside Kubernetes. So this allows for a very convenient way to scale your application both up and down. So if more traffic comes to your system, you can add more resources to it, create more instances of each service, or you can just choose which services you want to scale and which you don't want to scale, because you can have measurements and metrics of the performance of your system, so you don't need to scale your entire large code base because you only have network load, for example, in one service. You just need to scale that service, not the entire system. But also, this architecture, of course, has its own disadvantages. It's actually pretty complex to maintain, especially because it pretty much requires you to use this containerized approach, and even probably Kubernetes or some container orchestration system, because all this management of a lot of separate services can be really difficult, because you need to monitor each service's state, health checks, logs, and stuff like that. Also, because microservices have a lot of communications, external communications, they have more APIs and more network communications usually cause security issues. So you'll need to pay extra attention to the security. And using different programming languages can be both good and bad. And of course, you can employ different teams of programmers that are more comfortable with different languages. For example, you can use one team with C# knowledge to develop one service, and another team with JavaScript knowledge, and the third team with Python knowledge. And each of these teams can develop their own service, and they only communicate with each other via an API, usually a REST API, or some gRPC, or some standardized language agnostic API. But at the same time, it can be difficult to rotate teams. So if one service is written in Python, for example, and if that team was just one person, for example, who knew Python, and that person left, no person from other teams can help with that service anymore. So there's a disadvantage here as well. And the last, but not least, architecture is serverless. Unlike its name suggests, it's not like this architecture doesn't have a service. It's just a server, and just the server is managed by the platform. you don't need to manage the server by yourself. And the serverless solutions come in two flavors, which is known as function as a service, and the next one is I forgot. It's probably businessware or some. But it basically means it has the entire solution as a service. So function as a service usually means that you can run small functions, usually for short periods of time, and it can be especially convenient for small tasks that need to be run periodically by some schedule. But this function as a service approach can be bad for long-running tasks. So you need to choose carefully. If you need more persistent state or long processing, you'll probably need to choose a different solution, not a function as a service solution. And the BAS, I forgot how it's called, what this B stands for, solution is pretty much like a CMS. So it has the entire application that you can use directly without developing all this basic infrastructure. You can just customize this existing solution for your business needs. And so, of course, this serverless architecture has its own pros and cons. The advantage of it is it's easy to deploy, because all the infrastructure, all the servers are already pre-configured. They are managed in terms of health checks, errors, and stuff like that. So they are always recreated for you, and they also scaled up and down as needed automatically. So it can be really easy to use it. Also, if you use it for the right tasks, these solutions can be lower costs because they don't run like all the time, especially if you use the function as a service solution. You can just start your function by some schedule periodically, run it for 1 or 2 minutes, and just shut down the server afterwards and wait for another day. So yours is, yeah, sure. Backend, oh, right. Thank you. I forgot. Yeah, backend as a service, of course. So it's pretty much any hosted CMS can be thought of as backend as a service. All right, so the next advantage of this architecture is the enhanced scalability, as I already said. You don't need to manage the number of pods or containers yourself. The cloud provider will do it for you, doing all the metrics. It can guess how often your service is used and adjust accordingly. But of course, this architecture has its own disadvantages. First is vendor lock-in. If you use Amazon Lambda, for example, your code will not be compatible with Google Functions, for example. So every vendor has its own interface for services solutions. So it can be difficult to migrate to another service provider, unlike all the other architectures. Of course, with monolithic architecture, you can deploy your code to any machine that supports your operating system and just the framework that you're using. So we have a lot of choice for service providers. You can self-host your service, and you can choose from any cloud provider that you like. And the same goes with the service-oriented architecture. It's still pretty much the same, just separated between several processes. And with the microservices architecture, you're only locking yourself to Docker and Kubernetes, which are open source and pretty much industry standard. So you can still relatively easily migrate from one cloud to another. But it's not the case with the serverless architecture. And the other problem with the serverless is that it's not for long-term tasks. Of course, it only I'm talking about function as a service approach. Of course, with the backend as a service approach, it can be for long-term tasks as well. But FAS usually runs for very short periods of time, and you need to take that into account when you deploy your functions to these platforms. So to summarize all this, you can have all these kinds of architecture in the same system. For example, you can have a Kubernetes cluster with microservices, but each microservice can be a monolith of its own. It can still have different layers, like a data layer, business layer, and a presentation layer, and they can grow large. So it's really easy to create a new monolith, big service instead of a microservice. So you should be careful. Also, some parts of your system can employ this service-oriented architecture. They can communicate via some event bus, like enterprise service bus or stuff like that. And some small functions like cron jobs, for example, can be deployed into a serverless FAS, or just you have a CMS that also runs as a service. And all these parts can be in the same cloud provider, so you can have all these on your dashboard in Amazon or Azure. But also you need to keep in mind that different architectures are created for different purposes and for different kinds of projects. So monolith is probably good for startups and small apps. Service-oriented architecture is good for banks or other complex large enterprises. Microservices are good for large teams, and when these teams need to work independently and cannot communicate with one another frequently. And also, if you have a good understanding of Docker and Kubernetes, otherwise it's not a good idea to start with microservices. And as I already mentioned, you can start with a monolith and then refactor it into microservices. And as for the serverless, it can be also good for like CMS-like jobs or small functions that run periodically, but for short periods of time. And this is pretty much it. Thank you for your attention. Should you have any questions, I'll be glad to answer them. Yeah. API gateway similar to FAS. I'm not sure. FAS usually implies some really small tasks that run periodically. Like if you need to send a message to Twitter, for example, if you want to schedule your tweet, and if you need to generate it, you can create a small function, and that will generate your tweet and just shoot it to Twitter. But it's not like for complex enterprise tasks, because FAS runs for limited time. You need to structure your functions carefully, not to overload it. I'm not sure if API gateway, as far as I understand it, it's like a client-facing interface that hides the complexity of the inner system, but I'm not sure how it relates to FAS. Maybe you can clarify. Yeah, of course. It's a very good idea to integrate with all these services. All of them are very popular among developers. And of course, you can check out your code from GitHub and then push it to production in Kubernetes, or build Docker containers and stuff like that.